Hi everyone, so my name is Shamane and I lead the research team at Arcee.ai. So today I kind of want to talk about this new open source repository of us called PruneMe. It is kind of related to large language model pruning, which could potentially help the cost of fine tuning, pre-training, as well as reduce the inference cost. So let me first walk you through some of my slides, and then also if you have any questions, please feel free to drop it into the chat, and also I will have a Q&A session where you can ask questions directly. Yeah, so let's get started. And um, so, uh, continual pre-training. What is continual pre-training? It's all about when you have a base large language model. Let's say it could be Llama 3 or a Mixtral or something like Llama 2 even. So these models are kind of general purpose. They are really well, but there could be some use cases where you actually need to fine tune or pre-train them again with your domain specific datasets, right? So although we know like there are methods like parameter efficient tuning and all, but if you really want to go with something like continual pre-training, that means you want to like extend its knowledge with your own data set. That could be still a bigger problem, like it would be still expensive, like for example a model like Mixtral or model like Llama 370 billion. If you want like continual pre-training on 100 billion tokens, it would still take some considerable amount of time as well as money. So then we thought like, what about this concept called efficient continuous pre-training or continual pre-training, ECPTS. That means like, can we do this efficiently? Because there are papers that have shown, although PEF methods are good for fine tuning and DPO, like preference tuning, uh, when it comes to things like continual pre-training or more like unsupervised way of adding new knowledge, they can't kind of handle much knowledge, like, so you need to come up with better ways. So we thought of like, can we do this efficiently? That's where like we really like this pruning approach. So layer pruning, this is not a new technique. Like for example, we've been talking about pruning since the birth days, like even with these papers like lottery ticket hypothesis, like where researchers have already shown like most of these large models, they have a lot of redundant parameters. So if there's a way we can kind of reduce them, get what you need, that would be awesome, right? But this paper from Gromel et al., the unreasonable effectiveness of deeper layers, which is kind of a really new paper around April or March. I think it is from Meta as well. So they say like, actually there's a very stable mechanism to remove some of the blocks related to your own dataset when you're using these large language models. So we thought of like, kind of, why not try to implement it, because it seems like a very nice approach, and we wanted to test it, and it kind of worked as well, really well as well. So the if I want to explain about layer pruning strategy, it's more like, we know in a transformer we have several blocks, and we use residual layers in between blocks, and everything kind of get connected, right? So what they suggest is, so we can kind of first pick number of blocks to prune. Like for example, say Mixtral 32 billion, Mixtral 8 billion, 7 billion parameter model, it has 32 blocks, right? So you can think of, oh, I need to remove 8 blocks, or I need to remove 4 blocks. So what you do is, you kind of pick chunks of 4 blocks and compute the outputs, right? And then once you compute the output, you want to see like what outputs are kind of much similar. So if, let's say, between block 4 and between block 8, outputs are like kind of almost the same, their suggestion is we can remove that block. it makes sense, right? Like, because end of the day, it's all about the internal representations. So you take the hidden layer representation. Actually, in this, what they do is, after every block, you compute the like hidden states, and then you only take the last token's representation. It's kind of like the class token, but since these are like decode only models, you can take the last token, and then you kind of compare, that token's representation with the other uh, like representations that you take out of after few blocks away, and then you could keep doing it. So this is like the algorithm is kind of pretty simple as well. So first you need to pick a number of layers to prune. Like, let's say I need to prune 8 layers. Then you need to compute these distances, like distance of like representation of the, let's say, zero, like for example, zeroth layer, and then eighth layer. Then you can move up one. That means you start from the first layer and the ninth layer, like that, and then you literally compute the like angular distance. It's kind of, like we all know angular distance is pretty simple, and you kind of need to know which ones are closer. So then you try to find which block chunk, I would say. Like, it's like, just think like we go from 0 to 32 layers with 4 blocks in each step, and we find like, oh, what is the best block to churn, or best block to remove or prune. So this algorithm kind of gives that, and then you can remove that block, right? So the good part is, in the paper they have mentioned, when the large language models get larger, like for example compared to Llama 7b and Llama 70b. When it comes to Llama 70b, you can prune more layers, but when it comes to around 7 billion parameter models, they say you can kind of remove 35% of the layers. So yeah, this is pretty much it. And so you can check out the GitHub. Like, this is a fully open source project. All you need to do is you need to just use these you need to assign you need to assign a model. Like, it could be from the Hugging Face or anywhere, and you also need to assign a data set. It could be your own data set. Like, they say, like, you can, for this data set, you can use a little amount of data from your from your own domain, or like kind of a data set from a general domain, just like the forward parsing and averaging out this representation, and then utilize similarity between layer blocks to identify the optimal layers for pruning. And so there are so many use cases as well. Like, first thing is, imagine now you have a prune model which is like much smaller, and you can conduct your continual pre-training on that, right? And then obviously you can serve it, you can conduct SFT and DPO, then you can save some serving costs, right? But there are like far more advanced cases. Like, for example, like, we can think pruning and merging together as well at some point. Like for example, data flow space merging from Shamane.ai, like more like evolutionary merging algorithms, where they have shown like you kind of can stack layers together and all. So you have the prune model, it's been trained on your own data, and you have a bigger model which is a really good chat model or something. Then you can get some layers from it and can kind of chunk in between. Because in model merging, the harder part is when the models are coming from two families with different sizes of layers. It's really hard to conduct this kind of merging. But this approach will help you to kind of conduct that sort of merging methods as well. Yeah, so finally, Charles from our team, who is like the lead author of the merge kit, he actually used this method, and he pruned, I guess, Llama 70 billion to billion model, and created Llama 42 billion model. It's on the Hugging Face. I don't know whether it is that clear, but you can check this model Llama 3-42BV0. So what he did was he first pruned it, and then he also healed it. Like that means he kind of ran some instruction fine tuning with the general data set on that. So the results are really good. He managed for some, I can see for some benchmarks, he kind of managed to get almost the Llama 70B results. Yeah, like I think that is pretty much it from me, and I'm happy to take any questions, or if you have anything, just please. I'm happy to answer now. Yeah, that's a very good question. So the question is, model merging was hard if the number of layers are different. Actually, not just layers. It's just like if the layer sizes are different, right? So right now, most of the model merging can be done. Say you have a version of Llama 7B, like a Llama 7B chat model, you can merge it with Llama original model, right? So first things first, uh, like there's a theoretical thing as well, like for example, they should come from the same initialization. There are other methods where people have worked on, like let's say two versions of Llama 7B base. Like we don't have such Llama 7B two versions of bases, but only one. Like for example, right now to merge Llama 2 and Llama 1 and Llama 2, although they are exactly the same architecture, it won't give better results with these ties and AI and all this merging, because they are coming from two initializations. But here, what I said was, like say, even let's say two versions, smaller model and a large model, in order to even think of merging right now, you need to make sure those hidden layer sizes are same, right? Because otherwise you can't do it. It's more like an average in operation right now, most of these merging techniques. But this method, what you can do is you can get a Llama 70B, you can prune it, but still the hidden layers size dimensions are same, so you can kind of try to use it. Then yes, then the real deal is, can we merge two different architectures like mum um, and like Mamba type approach to reduce the layers before merge. So yeah, I I think it's a hard task. It's a hard task. I would say still a prune model like this would be easy to merge with another large model coming from the same family, but I haven't tried that part. Uh, it's like an open question as far as I know for the research as well, because like these layers are kind of initialized into some domain, so you might need to do some tuning or something after the merging if you want to like merge two different architectures. But yeah, it's like an open question right now in the research community as far as I know. Thanks. Okay, then that's all. So thanks a lot for listening, and yeah, please feel free to check out the repo. It's really easy. Just you need to run this stuff, picking your thing. Then once you know which layers to prune, you can kind of create your own model with Mergefit and uh, like upload it to the Hugging Face. And yeah, this is like some of the work I did with Mistral, Mistral V2. So you can see like if you take layer blocks, when it comes to like later layers, you kind of can see they are like almost a similar output. So you can remove this block 21 from 21 to 22 to 30 because I wanted to remove 8 layers here. But yeah, just comment us on our GitHub repo or anything. Let us know how it goes. Thanks a lot. Bye bye.